The standard we're looking at today is called ARCH.7.RP.A.1.7.1. The learning target for this standard is I can solve proportional relationship problems involving similar figures. So first of all, we're going to look at two similar figures and determine how they can form a proportional relationship. And I will take you through step by step. So we're looking at two rectangles. So the first rectangle has a length of 4 units, or in this case squares. So we can count starting from here, the bottom, 1, 2, 3, 4, and prove there's 4. And 1, 2, it has a width of 2 squares. The second rectangle, we're looking at it, and we see 1, 2, it has a length of 2 squares, and it has a width of 1 square. So when we make a little chart, we want to have the length of the first rectangle and the length of the second rectangle. We want the width of the first rectangle and the width of the second rectangle so that we can determine whether or not we have a proportion. So remember, we counted the length of the first rectangle is 4. The length of the second rectangle is 2 squares. The width of the first rectangle is 2 squares. And the width of the second rectangle is 1 square. So when you're writing it in this way, you have to ask yourself what you can divide 4 by to get to 2. And with your fact family, you know 4 divided by 2 equals 2. Now, if you can use this same scale factor for the denominator, then you can prove that they are indeed a proportional relationship. So you ask yourself, is 2 divided by 2 equal to 1? Yes, that's true. So this is a proportional relationship. As I said in the beginning, in the learning target, we were involving similar figures, and just to give you a little background on that, similar figures have the same shape, you can see that, but they do not have the same size. So let's look at another example where, in this case, these two triangles are similar. They have the same shape. But these two triangles are not congruent because they are not the same size. They would be congruent if they were the same size. Similar triangles have proportional sides. So what are the side lengths written as a proportion? Well, just like the rectangle problem, you're going to look at the length is equal to 1 here, and the length here is equal to 2. Here the width is equal to 1, and here the width is equal to 2. So, well, you might clearly see that 1 over 1 equals 1 and 2 over 2 equals 1. But you can also prove it by using scale factor. 1 times 2 does equal 2, and 1 times 2 does equal 2. So this is a proportion, which again shows you that they are similar triangles. The tick marks indicate equal measures of the angles. So I also wanted you to know that in similar triangles, the angles are always congruent to their corresponding angle. And the last example, testing for equivalent ratios is the same thing as a proportion. So proving again that there are proportional sides to these two triangles, which are similar, we are looking at, this time, we're looking at the length of this triangle here is 9. So you can see it went up to 9 from, I'm not sure if I can fit the whole thing on here, from 0. So we went all the way up to 9. And then the length of this smaller triangle is 3. So I have the length here and here. And then the width of this triangle is 6. And the width of this triangle is 2. So does 9 over 6 equal 3 over 2? Well, once again, if we had the same scale factor, then they are proportional. Is 9 divided by 3 equal to 3? Use the same scale factor. Is 6 divided by 3 equal to 2? Yes. So the sides are proportional and the ratios are equivalent. And that's the end of this lesson.